Hey friends, welcome back to my channel. Today we will discuss about what is infrastructure as code and how Terraform can help us with this concept. How does Terraform actually works and some of the commands of Terraform. So what is the traditional way of deploying an application? Someone from the operations team will get the details about the requirements and then the person will create virtual machines, connect them with virtual private network, create the database instances required by the application. You also need to make sure that everything is secured and only accessible with the required IPs, and also add some configuration required by the application. Also, all these resources needs to be created in a certain sequence, and this needs to be done first for dev environment, then for QE, then performance, staging, and finally for production. Not so great idea. So how does infra as code helps? Infrastructure as code, in simple terms, is a program written to create your infrastructure. Just like you manage your application using a source code, you can also manage your infra from this code. Now, what are the benefits we are getting here? First is automation and repeatability. IAC automates infra provisioning and configuration by representing infrastructure components and their configuration as code. This code can be version controlled, tested, and executed. Automation eliminates manual errors, speed up deployments, and ensure consistent and repeatable infra setups. For example, suppose setting up your infra using the code takes 2 hours. Since this is automation and you already have a time estimation, you can efficiently schedule the deployment. This will save a good amount of time. Next is scalability and flexibility. IAC enables dynamic scalability by treating infra as code. Users can define templates and scripts that automatically scales resources up or down based on workload demands. So if we consider the previous example, suppose the dev cluster needs 2 VMs of X configuration. For performance cluster, you need 5 VMs of X configuration. You can easily achieve that by changing a code at a single place. Unlike manual effort, where you have to repeat the same steps 5 times to create 5 VMs. Also, scaling can work based on the traffic and workload, which ensures optimal resource utilization and cost effectiveness. And here you also get flexibility in terms of size of infra. Suppose for dev you are fine with 2 CPUs and 8 GB memory, and for production you need to double the infra size. Then you can have different configurations and run the deployment. This brings us to our next point, version control. As we have said that this is infra as code, we get the advantage of version control system like Git. This means we can maintain different versions of our infra and deploy whatever version we find suitable. We can collaborate with team members, track our changes, and roll back if something breaks. Suppose the change in code is working in the dev branch and you want to deploy it to prod. You can simply push your changes in the production branch. So the dev team and production team can use the same code but with different branches, thus taking advantage of version control. Next we have is infra dependency management. IAC tools manage dependencies between infrastructure resources. The declarative nature of IAC allows users to define relationships and dependencies explicitly. These tools automatically handle resource provisioning and ensure the correct order of operations to maintain a consistent and functional infrastructure state. IAC promotes transparency and enhances monitoring and auditing capabilities. Infra configuration are codified and can be reviewed, audited, and documented. This transparency improves security, compliance, and the ability to track changes over time. IAC ensures consistency across environment by using the same codebase to provision the infrastructure. Development, testing, and production environment can be created with the same set of code and configuration, reducing the risk of configuration drift and ensuring reliable application deployments. Now, what is Terraform? Terraform is an open source tool created by HashiCorp. It helps in provisioning and management of infra. It plays a pivotal role in implementing IAC practices, allowing users to define, deploy, and manage infra resources across various cloud providers and on-premises environment. Code written in Terraform is declarative, which means you just write what is the end result that you want, and Terraform tries to reach that end result. Now, why Terraform? Terraform is designed as an IAC tool that treats infrastructure, provisioning, and management as code. It enables users to define infra resources, their configuration, and relationship using declarative language called HashiCorp Configuration Language (HCL). One of the significant advantages of Terraform is its ability to work across multiple cloud providers, such as AWS, Azure, Google Cloud, and many more. It also supports managing resources in on-premises environment and other infrastructure providers. This flexibility allows us to provision and manage infrastructure resources consistently across different platforms, avoiding vendor lock-in and promoting portability. They can even use different cloud providers at the same time. Just need to configure the authentication right. Next is declarative configuration. As I have said, that with Terraform you just need to define the desired state and the Terraform will figure out how to reach there. Terraform automatically manages dependencies between infra resources. When defining infra configurations, users can specify relationships between resources, such as referencing a security group from an EC2 instance. Terraform analyzes these dependencies and ensures that resources are created, updated, and destroyed in the correct order, maintaining the desired infra state. Terraform also introduces two-step workflow, plan and apply. During the planning phase, Terraform examines the infra configurations, compare them with the current state, and generates an execution plan. This plan shows the proposed changes of the infra, including resource creation, modification, or deletion. Users can review the plan before proceeding to the apply phase, where Terraform executes the plan and brings the infra to the desired state. Terraform uses a state file to store the current state of the infra it manages. The state file tracks the resources that Terraform creates and manages, their properties, and their dependencies. This state file is crucial for Terraform to understand the existing infra state and calculate the required changes during subsequent operations. It can be easily stored locally or remotely, depending on the user's preference and requirement. Community. Any technology out there works when there are people using it. The community of Terraform contributes to its development and also creates and shares modules to provision common infra patterns and provides support through forums, documentation, and online resources. So here you have got your configuration file that you have created. The configuration file defines the desired state of the infrastructure. Then there is this state file which stores the current state of the deployed infra. So initially, when there is no Terraform state file, Terraform will create one for you. You can store this file locally or on any cloud provider. Then both these items are taken into consideration by the Terraform core. After analyzing, it creates a graph to reach from the current state to the desired state. It also shares the plan with the user. Like, these are the resources that will be created, changed, or destroyed. Now, user can review the plan, and if everything looks fine, then they can go for the apply stage. And to provision the complete process, Terraform has some provider. Providers are used to connect to different cloud providers and execute the commands to create the infra. Terraform supports providers from all the major cloud providers. In the end, after the infra updates, Terraform also updates the state file with the latest changes. Now, if you are managing your production infra using Terraform, then it is highly recommended not to modify anything manually, whether it is your state file or the deployed infrastructure. Always go via the Terraform route. Now, why am I saying this? Suppose you modified something manually in your infra. Terraform will not be able to figure out what it is because it is not there in the state file. Similarly, if you added anything in the state file, then Terraform won't be able to control it smoothly. So only in the extreme emergency you should modify things manually. Else always go via Terraform route. That's it for the architecture side. Let's see some of the commands used in Terraform. Terraform init. This command initializes a Terraform project. It downloads the necessary providers and modules and creates a file called terraform.tfstate that stores the state of the project. Plan. This command creates a plan for updating the infrastructure. This plan shows what Terraform will make and it can be used to see the impact changes before they are applied. Terraform apply. This command applies the plan that was generated by the Terraform plan. It creates or updates infrastructure and also updates the tf state file. Destroy. This command destroys the infrastructure that was created by Terraform. It removes all the resources that were created by Terraform, and it also deletes the Terraform tf state file. You can destroy the resources by using -destroy flag in Terraform plan command, and this won't destroy the state file. Validate. This command validates the Terraform configuration files. It checks the files or syntax errors, and it also checks the files for logical errors. Refresh. This command is deprecated as of now, but this was used to refresh the state of Terraform project. It updates the state file with the latest information about the infra. Workspace. This command manages workspaces in Terraform project. Workspaces allows you to work on different environments such as development, staging, and production in the same project. Terraform output. This command prints the output of the Terraform plan. It can be used to see the values of variables resources that were created or updated by Terraform. Terraform state. This command manages the state of Terraform project. It allows you to view, export, and import the tf state file. That's all for today. I hope you have learned something new. If you have any questions regarding Terraform, you can ask me in the comment section. Don't forget to reach out to me on Twitter. Thank you.